Hello students, in this video I am going to solve numericals of refraction at plane surfaces from the textbook Concise Physics for ICSE grade 10. These are some of the important formulas that I will be using while solving the numericals of this particular chapter. So let us start exercise 4a, numerical number 1. The speed of light in air is 3 into 10 raised to 8 meters per second. The value of c is given 3 into 10 raised to 8 meters per second. Calculate the speed of light in glass V. Refractive index of glass is 1.5. Now we know that mu is equal to C upon V. Mu is equal to 1.5. C is 3 into 10 raised to 8 meters per second upon V. So if I make V as a subject, 3 into 10 raised to 8 upon 1.5, which can be written as 3 by 2. So the answer is 2 into 10 raised to 8 meters per second. Next question. Speed of light in diamond is 1,25,000 kilometers per second. So V is equal to 1,25,000 kilometers per second. Let us first convert this into meters per second, and that can be done by multiplying this value with 1000, right? 1 kilometer is 1000 meters per second. What is the refractive index of diamond? That is what we want to find out. So mu is equal to C upon V. C is 3 into 10 raised to 8 meters per second, and the speed of light in diamond is 1.25 into 10 raised to 8 meters per second. So 10 raised to 8 and 10 raised to 8 gets cancelled, and 3 upon 1.25 which can also be written as 5 upon 4. So this is 12 upon 5, or we can say 24 by 10, or 2.4. Okay, so refractive index of diamond is 2.4. Third numerical, the refractive index of water with respect to air. So that is refractive index of water with respect to air is 4 by 3. What is the refractive index of air with respect to water? Refractive index of air with respect to water we want to find out. So here we can use the principle of reversibility. According to the principle of reversibility, A mu W times W mu A is equal to 1. So if I make W mu A as a subject, it is 1 upon A mu W. That is 1 upon 4 by 3. 3 will go up in numerator. So 3 upon 4, and the answer is 0.75. This is the refractive index of air with respect to water. Fourth numerical. A ray of light of wavelength 5400 angstrom suffers refraction from air to glass. Taking A mu g is equal to 3 by 2, find the wavelength of light in glass. Refractive index is lambda 0 upon lambda, where lambda 0 is the wavelength in vacuum or air, and lambda is the wavelength in a given medium. So lambda, if I make as a subject, it's lambda 0 upon mu. Lambda 0 is 5400 upon 3 by 2. So lambda is equal to 5400 times 2 upon 3. That is 1800, 3s are 5400, and 1800 into 2 is 3600 angstrom is the wavelength. Now exercise 4b. First numerical. A ray of light incident at an angle of incidence 48 degree on a prism of refracting angle 60 degree suffers minimum deviation. Calculate the angle of minimum deviation. So here angle of incidence is given 48 degree. Refracting angle of prism or prism angle is given 60 degree, and we have to find out angle of minimum deviation. We know that A plus delta is equal to I plus E, but when delta is minimum, A plus delta minimum is equal to 2I. Prism angle 60 degree, delta M we want to find out, is equal to 2, angle of incidence is 48. So 60 plus delta M is equal to 96. So delta M is equal to 96 minus 60, and hence delta m is 36 degree. So angle of minimum deviation here is 36 degree. Second numerical. What should be the angle of incidence for a ray of light which suffers minimum deviation of 36 degree through an equilateral prism? So here we want to find out angle of incidence. Minimum deviation is 36 and prism is equilateral, meaning prism angle is 60. So once again, using this relation, A plus delta is equal to I plus E, A plus delta minimum. So I and E are same, so we can write 2I. Prism angle is 60, delta M is 36 is equal to 2I. 96 upon 2 is equal to I. So prism angle, sorry, angle of incidence is 48 degree. Now exercise 4C. A water pond appears to be 2.7 meter deep. It appears to be 2.7 meter deep, meaning that is the apparent depth, 2.7 meter. If the refractive index of water is 4 by 3, mu is equal to 4 upon 3, find the actual depth, that is the real depth. Mu is equal to Rd upon Ad. So if I make Rd as a subject, that is mu times Ad. Mu is equal to 4 by 3. Apparent depth is 2.7, or we can say 27 upon 10. 9 3s are 27. So 9 4s are 36 upon 10. 3.6 meter is the real depth. Second numerical. A coin is placed at the bottom of a beaker containing water to a depth of 12 centimeter. By what height the coin appears to be raised when seen from vertically above? So here what is given to us? Mu is given 4 by 3, and at what depth the coin is placed? That means real depth is given 12 centimeter. We want to find out by what height the coin appears to be raised. Appears to be raised. Okay, that is a normal shift. So normal shift we want to find out here. Normal shift is equal to real depth times 1 minus 1 upon mu. Real depth is 12. 1 minus 1 upon 4 by 3. So this is 12 times 1 minus 3 by 4. 12 into 4 minus 3 upon 4. So normal shift is equal to 12 upon 4, and that is 3 centimeter. So the coin appears to be raised by 3 centimeter. We can also find out the apparent depth here. Apparent depth is equal to real depth minus normal shift. Real depth is 12 centimeter and normal shift is 3. So apparent depth is 9 centimeter, meaning coin appears at 9 centimeter depth. Third numerical. A postage stamp kept below a rectangular glass slab of refractive index 1.5 when viewed from vertically above appears to be raised by 7 millimeter. Calculate the thickness of the glass slab. Now here thickness of the glass slab is nothing but its real depth. Okay, it is its real depth. So we can say normal shift is equal to thickness into 1 minus 1 upon mu. The normal shift is given 7 millimeter. We want to find out thickness, and mu is 1.5, which can be written as 3 by 2. So 7 is equal to T, 3 minus 2 upon 3. 7 is equal to T into 1 by 3, and hence T is equal to 7 times 3, 21 millimeter. 21 millimeter is the thickness of the glass slab.
Thank you for watching. Please like, share and subscribe to my channel.